Welcome back to Stage 1 Mathematics, Topic 4, Growth and Decay. In this video, we're going to look at Section 4, Simple Exponential Equations. An exponential equation is an equation in which the variable is in the index. For simple exponential equations, such that if a to the power of x equals a to the power of k, then x is equal to k. That is, establish the same base on both sides. If necessary, equate the indices. So that is, establish the same base on both sides. If necessary, equate the indices. So jumping down into some problems, we've got 3 to the power of negative x is equal to 81. So 3 to the negative x is equal to 81. Now ask yourselves, how can we get away with writing 81 as a power of 3? And if we know that, say for example, the factors of 81 can be 3 and 27, 3 and 9, and then 3 and 3, like so, we know that we can write 81 as 3 to the power of 4. And therefore, by association, we know that x in itself, or negative x I should say, is equal to the power on top of the 3 on the expression on the right hand side, which equals to 4. And therefore, x must equal negative 4. Not too bad. Now over in B, we've got 6 to the power of 2x minus 3 equals 1 over 216. So once again, we're asking ourselves, what do we need to do, or how can we express 216 as a power of 6? So we can go 1 over 6 to the power of what? So we can write this as 216, and let's factorize. We know it's going to be divided by 6, and what will be left over is 36, and then factorizing that again, it will be 6 times 6. So what we can see is that 1 over 6 to the power of 3, or 6 cubed. And writing that down, we're going to get 6 to the 2x minus 3, and then that will be equal to 6 to the power of negative 3. So therefore, by association, we can see that 2x minus 3 is equal to negative 3. Adding 3 to both sides, we get 2x equals 0. Therefore, x itself, in turn, must also equal 0. So this would be the solution to example B. Going down, we've got 16x minus 3 is equal to 1 over root 2. Now again, we have to ask ourselves, how can we get this in the form of 16 to the power of x minus 3? How can we make the right hand side look like a similar form to that? So we can do it, but we can take a slightly different step. So we'll modify both the left hand side expression and the right hand side expression. So firstly, 16 is a perfect square number, and it can be distilled down to 4 to x minus 3. And we can do one better as well, and we can go 2 to the power of 4 x minus 3, like so. And then on the right hand side, we can change this to 2 to to the half over 1, and then we can change it to 2 to the negative half, like so. And therefore, by association, we've got a common base. So we can say that 4x, or 4 times x minus 3, is equal to negative a half. And then multiplying both sides by 4, or dividing both sides by 4, I should say, we're going to get negative 1 over 8. And then adding 3 to both sides, we're going to get 3 minus 1 over 8. And then expressing that as an imperfect fraction, we're going to get x equals 23 all over 8. So x would equal 23 over 8. Now going across to section D, notice that we've gotten everything equal, or everything on the left hand side is equal to 0. So the way in which we can approach this question is, firstly, we'll see if we can simplify, and this 9x, we can definitely simplify that down to 3 to the power of 2x minus 7 times 3 to the power of x minus 18, like so, and all of that is equal to 0. Now notice this is where things start to take a slightly trickier route, and we have to use the quadratic equation to explain this sort of expression to solve it. So what we're going to say is 3 to the power of x, and we'll have that all raised to the power of 2, minus 7, 3 to the x minus 18, all equals 0. Then we're going to say let, and we'll call it z this time, equal 3 to the power of x. Then 0 will equal z squared minus 7 minus 18, like so. And now we simply solve for this quadratic right here. What two numbers multiply together to give 18 and add together to give negative 7? And we find that they're going to be negative, positive 2z minus 9z, take 18, then simplifying, we're going to take out common factor of z there, plus 2 minus 9 minus 9, and that will be positive 2 there. So therefore, we're going to get z minus 9, z plus 2. So therefore, z equals positive 9, or it equals negative 2. And remember, we're not searching for z, we're searching for 3 to the power of x. So we're going to say 3 to the x equals 9, or it equals negative 2. So rewriting this as say an index, we got 3x, then 3 squared, and then negative 2. But remember, we have to have positive values for, or 3 to the power of x has to give us a positive value. So we expect that 3x has to be greater than 0. So we can get rid of that possible solution there, and therefore we find that x has to equal positive 2. So this one's a little bit of a tricky example, and it requires a bit of a keen eye for searching for a pattern, but this would be the way in which we solve this style of question. Now let's move onwards to question E. We've got 5 to the power of x equals 10. So setting off like we usually do, we go 5x to the power of n. And then we have to ask ourselves, how can we get these two in a common base? And we've got 5 there, and we've got 10 over here. So the easiest one to go with would be, we'll start with 10, and we'll say, well, what are the factors of 10? And we break it down and we go 2 times 5, like so. And then we'd run into the dilemma and we'd find that, we can't actually factorize this any further. So we've got 5 to the power of x and then 5 times 2. So this particular problem right here, we find that we don't quite have the tools to deal with it yet. So we're going to leave this one here for now, and then in the subsequent videos we're going to look at gaining the tools to be able to solve problems like these.